First equation is angular acceleration is equal to a constant. For all the problems that we're going to deal with in this class, in order to use any of these equations that come after this, we need for angular acceleration to equal a constant. Okay, so that's our very first equation. Our second equation is we're going to deal with the idea of what acceleration is. Now, we talk about angular acceleration being how much increase or decrease in velocity an object experiences per a given amount of time. Expressing that mathematically, we would say that this is true for angular acceleration, that's equal to the change in the angular velocity for a given amount of time. Using calculus notation, that we can say this instead, meaning basically the same thing, just over a smaller and smaller chunk of time and space. So both of these hold true. Using that, we're going to come up with our next equation. So if I say that alpha is equal to a constant, okay, and that alpha here is nothing more than the change in velocity with respect to time, okay, that the change in velocity with respect to time is equal to a constant. Nothing new there. Now what I'm going to do next is I'm going to integrate that with respect to time. So I'm going to have the integration of the change in my angular velocity over time with respect to time is equal to the integration of a constant with respect to time. Now, wonderful thing about constants is that the integration is really trivial. So these cancel out, and I'm left with this equation. Omega is equal to, and we'll call that omega final, is equal to this constant times time plus another constant. Okay? This constant times time plus another constant. And I'll leave that little mark on there to let you know it's another constant. Well, C is equal to A. So I get omega final is equal to alpha times T plus that constant. Okay? Now, the next thing is you got to think about it. Okay, so what affects how fast an object is rotating? Well, obviously, if there's a change in that object's rotation, how fast it's rotating, that's going to have an effect on it. That value in which it gets increased by or decreased by per second times time is going to tell me how much my angular velocity has changed in, over that time. Now, what else affects it? The C prime. What other thing can affect how fast an object is moving, or how fast an object is moving after a period of time? Well, it's how fast it's moving initially. Its initial angular velocity should have an effect on its final angular velocity. So rewriting that equation, I get angular velocity final is equal to angular velocity initial plus angular acceleration times time. Okay, so that bottom line is our second equation. Our first equation is this angular acceleration as a constant. Our second equation is this angular velocity is affected by its initial angular velocity plus any changes in that angular velocity. Okay, those are the two equations. I'll come back for the third one in the next movie, and then the other three.